We're going to look at definitions of what it means for an argument to be inductively strong. Let's first remind ourselves of what it means for an argument to be valid. An argument with premise P and conclusion C is said to be valid when it's impossible for the premise to be true and the conclusion to be false. That is, when P and not C is impossible, or even more formally, when there's no truth value function that makes the conjunction P and not C true. In a picture, when we draw the P region, all the ways in which P is true, that should be completely contained inside of the C region, where all the ways that C can be. So, if we highlight the P region here in light red and the not C region in light blue, we see that there's no place where P is true and C is false. So that's what it means for an argument to be deductively valid. So to summarize, an argument with premise P and conclusion C is said to be deductively valid when there is no truth value assignment that makes P true and C false. An equivalent way of defining deductive validity is to say that every truth value assignment makes P imply C true. That is, the implication P implies C is a tautology. And yet another way to define what it means for an argument to be deductively valid is to say that there is no truth value assignment that makes P and not C true. That is, P and not C is a contradiction. But what we're interested in is what it means for an argument with premise C and conclusion C to be inductively strong. So here's a working definition. An argument is inductively strong if it is improbable that C is false while P is true. So the key idea is to replace impossible with a weaker notion of being improbable or not very likely. So while a deductive argument has the premise region completely contained inside of the C region, in general, an inductively strong argument is just going to have some overlap between the P and C region, and then it's going to be improbable that C is false while P is true. So what exactly does it mean to say that it's improbable that the conclusion is false while the premise is true? Well, one direct way of formalizing that is to say that this happens when P and not C is improbable. So the conjunction P is true and C is false is not very likely, it's improbable. That actually is equivalent to saying that the implication, if P then C, is probable. That is, P implies C is probable, it has, say, high probability, is true if and only if P and not C is improbable. And that's because P implies C and P and not C are contraries. Or said differently, the negation of P implies C is logically equivalent to P and not C. Or tautologically equivalent to P and not C. So this by implication here is a tautology. Since these two things mean the same thing, P implies C is going to be probable, is going to have high probability, if and only if P and not C has low probability. However, this definition is not going to give us exactly what we want, and we can see that by looking at two examples. So here's the first example. Suppose that the premise is there's a 2,000-year-old man in Cleveland. And then the conclusion is there's a 2,000-year-old man in Cleveland who has 3 heads. Now, this is a bit of an outlandish argument, but the one thing I want to notice, so intuitively, this argument is not inductively strong. Why on earth would somebody that happens to be alive, that happens to be 2,000 years old, why would that person have 3 heads? However, P and not C is improbable. That conjunction has very low probability. And why is that? Well, P P by itself is completely improbable. So the premise, there's a 2,000-year-old man in Cleveland, is very improbable. So of course this conjunction is also improbable. So according to our definition, we would classify this argument as being inductively strong. However, intuitively, we don't want to classify it as being inductively strong. Here's another example. There's a man in Cleveland who is 1,999 years old and 11 months, and this person is in good health. So therefore, no man will live to be 2,000 years old. Now, again, we think of this argument, or intuitively, this argument is not inductively strong. If there really is a man in Cleveland that is 1,999 and 11 months old, and this person is in good health, we actually do have a good reason to believe that it's not true that no man will live to be 2,000 years old, because this person seems to be evidence of somebody who will live to be 2,000 years old. However, again, so this argument here is not inductively strong. However, P and not C is improbable. Now, why is this improbable? Well, it's because this conclusion here, no man will live to be 2,000 years old, is highly probable. So that means not C has very low probability. So this conjunction here, P and not C, will have very low probability. So saying that an argument is inductively strong if P and not C is improbable gives the wrong answer on these two examples. And what's the problem? Well, the key problem is that when we say that an argument is inductively strong, so from P to C, so an argument with premise P and conclusion C is inductively strong, we're making a claim about the relationship between P and C. That P provides some type of evidential support for C. And just calculating is P and not C improbable, this might have very low probability without there being any evidential relationship between P and C. So the inductive probability of an argument is going to be determined by the evidential relation between its premise and its conclusion, not by the likelihood of the truth of its premises alone or the likelihood of its conclusion alone. So how are we going to measure this evidential relationship between the premises and the conclusion? Well, here's an example. So consider the argument, there is intelligent life on Earth, so therefore there's intelligent life on Mars. Well, this is not a very good argument. This premise doesn't provide very much evidential support for this conclusion. But suppose that we add additional evidence. There's intelligent life on Mercury, there's intelligent life on Venus, on Jupiter, on Saturn, on Uranus, on Neptune, and on Earth. All of this together does provide good evidential support that there's intelligent life on this other planet in the solar system. So how are we going to measure this evidential support? Well, that is exactly what conditional probability was designed to do. So the inductive probability of an argument is the probability that its conclusion is true given that its premise is true, or under the supposition that the premise is true. And we're going to measure that using conditional probability. So as a reminder, the probability of C given P is going to be the ratio, the probability of C and P divided by the probability of P. So going back to our examples, there is a 2,000-year-old man in Cleveland, so therefore there's a 2,000-year-old man in Cleveland who has 3 heads. This is not inductively strong, and indeed, if you think about it, the probability of this conclusion that there's somebody that is 2,000-year-old in Cleveland who has 3 heads, given that there's a 2,000-year-old man in Cleveland, that probability is quite low, because this premise doesn't provide any evidential support to raise the probability of this very unlikely conclusion. Similarly, with this example right here, if there really is a man in Cleveland who is 1,999 years old and 11 months old and in good health, then we do think it's probable that there will be a man that will live to be 2,000 years old. So the conclusion, no man will live to be 2,000 years old, that conditional probability is going to be low. And so we would judge, according to this definition, that this argument is not inductively strong. So in a picture, this is what's going on. We have this argument here with premise P and conclusion C. If we were to measure the probability of if P then C, then what we would be measuring is the probability of this blue region right here. Whereas if we look at the probability of C given P, what we do is we suppose that P is true, and we pull out that P region, and we reevaluate the probability of C given that we restrict attention to this P region. And so in general, these two probabilities are going to be different. So let's look at an example to further illustrate this definition. Consider these two arguments, argument 1 and argument 2. So argument 1, the premise is A or B, and the conclusion is A. So for example, argument 1 might be, you will either get an A or B in Philosophy 171, therefore you'll get an A in Philosophy 171. Argument 2, the premise is A or not A, and the conclusion is A. So for example, it might be, either you'll get an A or you won't get an A in Philosophy 171. Therefore, you'll get an A in Philosophy 171. Now, neither of the arguments are valid. So both argument 1 and argument 2 are invalid. However, intuitively, argument 1 is stronger than argument 2. That is, we might say that argument 1 generally is stronger than argument 2. And why is that? Well, we can see that if we look at the Venn diagram. So argument 2 here, where the premise is A or not A, notice A or not A is a tautology, so you're going to highlight the entire space of possibility. And A is just going to be a subset of A or not A. So it's going to be A or not A is not going to provide any additional evidential support for A that you don't already have. Now, you might initially think that it's very probable that you're going to get an A in Philosophy 171, but me providing you the evidence that either you are or you are not going to get an A can't provide you any additional support for A. On the other hand, A or B does restrict the set of possibility. So this probability of A, the probability of this A region, might in fact go up if you learn that A or B is true. And so A or B very well might provide additional evidential support for A. So that's our working definition so far. An argument is inductively strong if C is probable given P. That is, the probability of C given P is high. Now, what exactly does it mean to say the probability of C given P is high? Well, one way to understand that is just to say the probability of C given P is above some fixed threshold. And it's typical to assume that that threshold is 0.5. So that'll be our general working definition if we say the probability of C given P is high or the probability of C given P is probable. What we mean by that is the probability is greater than 0.5. So one natural question you might ask is, are we missing any other conditions? Is this all there is to saying that an argument is inductively strong?